Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving LeetCode problem 200, number of islands. At the moment, this is a really popular question with Amazon, Microsoft, Bloomberg, Google, and Facebook. So if you've got an upcoming on-site interview with any of these companies, this is definitely going to be one to know. Let's read the question prompt and think about how we might solve this conceptually. Given an m by n 2D binary matrix grid, which represents a map of ones, land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Cool. Now let's look at an example. If we were given this input here, this grid, what would we expect? Well, we expect an answer of 1. But how did they actually derive this? Well, remember that an island is formed by connecting adjacent lands horizontally or vertically. So what that means is that we can connect all these lands, right? These are all connected like this, and that is our island. And there's no actual other islands in this grid, so we only have that one big island. In this grid, we expect an answer of 3. Let's see how they got that. Well, this is one island because these are all connected. This is one island because it's on its own here, and this is one island. Notice that these islands are not one big island because it tells us that we can only have an island by connecting horizontally or vertically. We are not allowed to go diagonally in either direction. So it has to be up, down, or left and right. Cool. So if you've already seen my problem solution for the LeetCode, I think it was 653, max area of an island, you'll know that we're actually going to solve this in very similar way. Essentially, what we want to do is we want to iterate through our grid row by row and column by column. And what we're going to do is the first time that we see a 1, what we're going to do is we're going to kick off a depth first search in all 4 directions, and we're going to basically find all the ones that are connected to this 1 here. And we'll do that for every single one we see in the depth first search. So for example, we'd start at this one, and then we'd go to this one, and then we'd find this one, and then from here we'd go here, and essentially we'd find the entirety of our island. And what we need to do is also make sure that we don't get caught in an infinite cycle. So what we want to do is actually, every time we see a 1 in our depth first search, we're actually going to set it to a 0 to make sure that when we go back there from the next island that's touching it, we don't reset it to 0 because we actually, we don't want to get caught in an infinite loop. And when we were finding the max area of the islands, we had to count the area. But this time, we actually don't need the area. All we would need to do is just set these equal to 0 so that we just get rid of them. So then that way, when we finish our depth first search and we're continuing to iterate, row by row and column by column, essentially, after we've processed this first one, then we're going to be at this position, but this will have been set to a 0 as well as every other one in this island. So that means we won't kick off the process again and recount this island. So essentially, this problem boils down to 2 things. When we see a 1, we're going to, we're going to say islands, plus plus. We're going to increment our islands count, and then we're going to do, set ones to 0. And you'll have to excuse my terrible mouse drawings here, but you get the idea. So what we're going to do is we're going to set all of the ones in that island to 0, and, we're going to count as if we had seen 1. So, let's look at this example and kind of make it a little bit more clear. So we're going to go row by row, and let me just delete all of this here so we don't clutter the screen. So we're going to go row by row, column by column. So we're going to start here, and we see that this is a 1. So we're going to say our island count is now going to be 1. And we're going to set this equal to 0, and we're going to kick off the depth first search, right? So we're going to go to this right one. We're going to see it's a 1. We're going to set it to 0. We're going to try to go up, but this is actually outside of the bounds of the grid, so we don't do anything here. We go to its right. We see it's already 0, so we can terminate the depth first search there. We go to this 1. We see it's a 1, so we set it to 0. It tries to go to its right, and then it terminates. It tries to go down. It terminates. It goes to the left, it's a 1, so we'll set this equal to 0. Again, this will go up, but this is already a 0 because we've set it. Tries to go out of bounds, tries to go down, tries to go back. And essentially what we're going to do is we're going to set all the ones in this island here to 0. Then we're going to continue. So we'd be in our original for loop where we're going row by row, column by column. So now we're here, but this is a 0, so we don't do any processing. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, we get to a 1. So now let's increment our island count. So it's now 2. And then we're going to set this to 0. And again, we're going to try to go in all 4 directions, but we're actually going to see that all of these are already 0. So every time we hit the 0, we're actually just going to terminate that depth first search, and eventually we'll just come back here because there's nothing to set other than this original 0. So then we're going to continue with that original for loop through the rows and the columns. So we'll see that this is a 0, this is a 0, this is a 0, this is a 0, this is a 0. Then we'll get here, so we have a new 1, so that means that we have another island. So we now have 3 islands. We'll set this to 0, and then we'll go in all 4 directions. We go up, we see it's a 0. We'll go to the left, it's a 0. We'll go down, which is out of bounds, which we're going to consider as a 0 because it tells us that, where is it? All 4 edges of the grid are surrounded by water, so we can just assume that outside of the bounds, it's always going to be water. And then we go to the right, and we see it's a 1. And since it's part of the search for the original one, we don't increment again. So, this gets set to 0, and this is going to try to go up. This is a 0. This goes out of bounds, which is considered a 0. This goes out of bounds, and then this goes here, which is already a 0 because we just set it. So that means this DFS will terminate. Then we'll be at this last one for our, row and column iteration, and then basically this is already a 0, so then we terminate. And then we just return our final answer, which is going to be this 3 here. So that's how we're going to solve it conceptually. Let's go to the editor and actually put it into code so you can see how we're going to. Now that we've seen how we are going to solve this conceptually, let's actually write the code out and you can see how it's implemented. So we know that we're looking for the number of islands. So let's define a variable for that. So we're going to say num islands equals 0. And remember, we said we need to look 4 directionally when we encounter a 1. So let's define that so we can use it anywhere. So we're going to say directions, and we're going to say 1, 0. So these are all the 4 directions we can travel. And I think we just need -1. Yeah, okay. So those are our 4 directions we can travel. And what did we say we're going to do? So we said that we're going to go row by row and column by column. And every time we encounter a 1, we're going to increment our islands count. And then we're going to set all of the ones in that island to 0 and then continue processing. So that way we can just count all the distinct islands. And since we set all the other ones that it's touching to 0, we won't double count. So let's actually do that. We'll say for row in range len grid. And we're going to say for call in range lang grid of 0. We're going to say, okay, if grid of row call equals to 1, and I hate that LeetCode uses strings here because usually it gives you integers. They're just trolling you here. It's really annoying. Be careful with this. If you get this in an interview, this might actually screw you over if the interviewer, if it's given to you as strings and you use integers. So just watch out. Sometimes they like to pull these kind of shenanigans. Anyway, so if it equals to a 1, what we need to do is we need to increment our island count by 1, and then we need to set the island ones to 0. So let's actually call a function for that, and we'll say set island zeros, and it's going to take the grid and it's going to take the row and the column, right? And at the end, all we would need to do is just return the number of islands. So let's define this function here to set the island zeros. Set island zeros. We're going to say grid. Actually need to define it. Def set island zeros, and it's going to take the grid, it's going to take the row, and it's going to take the column, right? So like we did with the problem to find the max area of an island, we need to make sure that when we're calling our depth first search that we're actually within the bounds of the grid and that we are at a 1. The reason why we want to check the bounds, obviously, if we try to access the indice that's outside of the bounds of our grid here, we'll have an index error, and then our code will blow up, and we don't want to do that. So we want to make sure that we're actually in the grid. So what we're going to do is we're going to say if, so we need to check our conditions here on the boundary. We're going to say if the row is between, the grid parameters, and also the column needs to be within the grid parameters. And we actually need to be on a 1, because that's what we're interested in. Equals to 1. Be careful with the strings. What are we going to do now? Well, we said that we need to set all 1s in an island to be 0, so that way we don't get caught in an infinite cycle. We don't double count things. So we want to say grid of row column is going equals to 0, so that us setting it to 0. And again, be careful with the strings. Now we just need to go in all 4 directions. So we're going to say for row increment, column increment in directions. What we're going to say is we're going to say set island zeros, and we're going to pass the grid in, the row plus the row increment, and the column plus the column increment. And that's really all we have to do. Now, I think it is worth noting, and I did mention this in my other video, that this assumes that you're allowed to actually modify the original grid. This makes it easy for us because we can just look up the value in the grid with this check here to check if we've been there before or if it's an invalid value. If you're not allowed to do that, sometimes the interviewer will say, hey, I don't want you modifying the input. What you're going to need to do is you're going to need to define a separate set data structure to basically hold the coordinates, the row column points that you've been to, and then you can do that check there to make sure that you actually haven't been there before if you're not allowed to overwrite this, and that's really the only way you can get around it. But in our case, we are allowed to do it, or at least the problem here doesn't stipulate that we're not allowed to do that, so we're going to just do it that way. So let's submit and check what our answer would be. Cool, it works. Before we go, I think it's always important to think about the time and space complexity of our algorithm. So if we think about it, we're iterating over the entirety of the grid, row by row, column by column. So time complexity wise, in the worst case, we're gonna have to touch every single piece of the grid right? Because if it was all zeros, we would still have to iterate over row by row, column by column. So we have to touch every single point. So our time complexity is going to be big O of the number of rows times the number of columns, right? And then the space complexity, well, again, like the problem where we're finding the max area of the islands, if we're counting the recursive stack frames, it's still going to be rows times columns, because we could have the case where we have one big island that spans the entire grid, which means that we would have to basically hold the entirety of our kind of recursion in that one stack frame. So it would be, rows times columns. Otherwise, it's going to be big O of 1, if not counting stack frame. So this is something you can bring up to your interviewer. It shows that you kind of think about these sort of things like, hey, are we counting the recursive stack frames? If not, then it's actually constant time. It's just good. It's just good to have these things in your mind and bring them up in the interview. Anyway, that's how you solve LeetCode problem number 200, number of islands. I hope you enjoyed this video. If you did, please like, comment, subscribe, and make sure to check out my other videos if you have an upcoming on-site interview. Happy coding!